Okay, hello everyone. This is a very quick tutorial on how to do the calculations for your puck experiment. So I've just got the data written here. So looking at the blue puck first, if you recall our puck, and I'm just going to do a very quick sketch. Our puck was travelling in one direction, which we've calculated or determined as 62 centimetres per second. After the interaction with the second puck, it's diverted off in a second direction, and we determined that that was at 48 centimetres per second, and we've also determined that that angle that it makes there is going to be 69.4 degrees. So now I need to do some vector calculus. First thing I need to remember is that we're after the change in the velocity, which is going to be the final velocity v minus the initial velocity u. The second thing we need to remember is we don't actually subtract with vectors, we actually add the negative. So what I'm going to be doing is taking the final velocity and then adding the negative of the initial velocity. So the negative of the initial velocity is literally just redrawing that vector in the opposite direction. So minus u is going to go in that direction there. So I'm still going to have the same v. This is my velocity vector v. This is my initial velocity u. So I'm going to redraw that first because that's one that is the same. And I know that is still at 69.4 degrees, and that was 48 centimetres per second. And now this is actually going to be going in that direction. I want to connect it head to tail, so I'm going to draw it in here. So like that, 62 centimetres per second. So what this means is that we can get an indicative idea of the direction of our resultant vector. So our resultant vector should be that vector there. Now this is only indicative. I haven't done any calculations yet, and now we need to look at how we're going to find those calculations. So the first thing we're going to do is actually look at this vector here and actually break it down into its components. Remember that 48 degrees, that 48 centimetres per second is actually made up of two components, a part in this direction and a part in this direction. So if I look at these two parts separately, remembering this is 69.4 degrees, then I can then equate with what's going on here. Because what I really want to do is I want to find the information of this vector here. So if I draw a line straight down, I want to be able to solve that triangle there. So to solve that triangle, I really need to know what that distance there is and what that distance there is. And I can do that from the information that I've got here. So remember, this is going to be 48 sine 69.4 degrees, and this is going to be 48 cos 69.4 degrees. So now I'm going to go to my calculator. Okay, so I'm back with my calculator, and I'll just plug in these values. So this is 48 sine 69.4 degrees, and that gives me 44.9, and remember that's still centimetres per second. And then the other value is going to be 48 times cos 69.4, and that gives me 16.9 centimetres per second. So what I know now is that this section here, from here to here, is 16.9, and this height here is 44.9. So knowing those two pieces of information, I can use Pythagoras to calculate what that size is there, and I can then use trig again to try and calculate one of those. So I'm going to redraw the triangle. There we go. So this is now what this vector is made up of, these two components. Oh dear. And I apologise for my very pathetic drawing. So this was 62 from here to here. I now want to subtract 16.9. So 62 minus 16.9. So this is 45.1 centimeters per second, and this one is 44.9 centimeters per second. So I think you can see that we've got very, very similar size lengths here, which means this is going to be very close to 45, and this is going to be very close to this number root 2. Let's put it into the calculator. 44.9 squared. Oh, and just taking care here, we don't put that in first, plus 45.1 squared, close bracket. So this ends up being 63.6 centimeters per second, and then we can use either one of these sides. Let's use our theta, call that theta there. It's going to equal tan to the inverse 44.9 over 45.1, and that's going to give us, okay, so you can see the calculator, tan bracket, oh clear, second tan bracket 44.9 divided by 45.1, close bracket, and that gives us 44.87, so let's call it 9 degrees, and as I said, very close to 45 degrees for our angle there. Okay, so that's enabled us to solve. If we're going to actually then, if we were asked to do this and actually quote it as a bearing, remember as a bearing, bearings are all about the fact of where we start to where we finish, taken from north. So this would be the angle we'd quote as our bearing, because we would say this is where we start and we have to turn to that direction to actually get the direction of the vector. So the velocity vector for the blue puck, so let's call it V, the change in velocity for the blue puck is going to be equal to 63.6 centimeters per second. So our final vector is 63.6 centimeters per second, and by adding 270 to this final angle here, we get 314.9 degrees true.